Okay, I know you can see my face. Let me make sure this is working in the background for a moment. Let's try this. I need to hear a volume check. I had the last video because of this. Give me a second. What's up with Google? Said allow the volume, and it's not working. 2 for 2 that failed. 2 for 2. Again, testing. 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 2 for 2. Okay, now we're working. Okay, let's try it one more time. Let's see, I'll get it going. And testing. Okay, I gotta recycle that, I believe, and I'll edit out the beginning of this video when Google allows me access again. Let's jump back into it. Okay, so I've got to start that video again. Brakes. Pascal's law, hydraulic forces. It's just fluid. Any fluid. Fluid in your bloodstream. Your pump, your heart. It pumps one little pump. That one little pump translates all the way down everywhere. All the arteries, all the veins, all them experiencing forces. All right. I did that to help, emphasize that your heart is part of this deal. See that little air bubble there? We don't want air bubbles in our heart, in our arteries either, right? They'll get there and give us strokes and stuff like that. You don't want air bubbles in your brake lines either. You bleed them out, you bleed them out. I see in theory, the air would be coming out there, except for the shape of this guy. It allows the air to hide into the corners of it. And I think I'll still have air in it. As I'm looking here, you'll see that air bubble. It's also how you can create a level if you wanted to. If you needed to, you could use this as a level. If you could figure the center line out and that bubble became dead center, you would have yourself a instant level if you needed it. All right, so also has to have a bit of a crown on it, so the air would go to the top. If I think of this as your brake line, your master cylinder, your foot pedal. If you have a hole in your hydraulic lines anywhere or your brake calipers, and I'm going to show you, Eric, the car guy, and anyone else, I'm going to show you one more, and another guy that dropped the ball on this whole topic. It's making me do videos, and they showed up. So as I pressed in YouTube, so as I press the button, as I press the plunger, fluid comes out. If this was sealed, all the forces are going to, from that hydraulic forces, are going to act on my palm of my hand. So I am pressing it. But I'm acting like a seal here. My finger's acting like a seal. If I release the seal, then I get a leak. So if you look into your master cylinder and you see a fluid going down, somewhere you have a leak. You have a break in your line, whatever it may be. You should not see a fluid go down unless you're bleeding air out of it. You should have a shield system, which the same amount of fluid is going to remain. It won't evaporate. It's going to remain in there. There's nowhere for it to evaporate to, right? Now let's go live onto, I'm going to cycle the screen off of here into shared screen. At shared screen, I will then enter, good. I will then enter the video part, a presentation part to help you understand this. Yeah, and we're going to get to that. And I have to verify that we actually are watching it. So let's go to, I have a couple of things lined up for you, but let's hit Eric, the car guy first. And I did that on my other channel, but before we do that, so stuck caliper, no, it is piston. Oops, I hate when I do that. Okay, so much for that. Okay, let me go ahead and show you. Oh, I wanted to show you that. I have to show you that. So it's Eric the car guy. Let me jump into his video real quick. This is how to rebuild a brake caliper. It's not that one. Okay, it might be this one here. So let me right click and open that up. And here we go. I think that's it. Let me pause it there and let me make sure I've got volume on your side because Google keeps screwing me up. Oh, I wanted to show you that. Okay, good. We're good. We're good. Anybody over here yet? Just watching? Good. Now, let's go. We're talking about Pascal's law. This is hydraulic forces. They're going to translate inside a closed system. And I'm going to fast forward to where he has it on the bench. Give me a minute. Where's your bench? Where's your bench? Stuck rear caliper. Piston is what I'm looking for, not caliper. Perhaps it is this one. Let me scrub it. Bear with me. It's going to be worth it for you. No, I think it's this one. I need to see him on the bench. I'm looking at the little thumbnails. It's going to be worth it. Come on. Come on. Piston, jump. It's a very small section. Very small section. Well, you get to play along with me here. Please play along. Play along. It's going to be worth it for anybody who came here to figure out that what the importance of this is. You'll see it for yourself. You'll understand it logically. And you'll see why you should not trust guys like Eric, the car guy here. With that said, Eric does get some real professionals on here that will help him in his videos. But oddly, it doesn't seem to translate to his own knowledge somehow. Brake piston sticking. Let's try that. I don't want that. I need Eric, the car guy. This is quite irritating. I apologize. Eric, the car guy. Let's try that. I just had it on the other channel, and now it's bounced off. How to spot a service stuck rear caliper. That's the one we just saw. So then it's brake caliper. Maybe it was this one here then. 31 minutes. And fast forwarding. Yeah, this is the car. All right, so here we are here. Let me jump forward. I'll give you a little volume.
It will damage the seal over time, and
let's back it up.
That I don't advocate rebuilding calipers that often, because just replacing the seals, well, that's all well and good, but this is your real issue right here. You see this rust and all this pitting. This pretty much makes this.
So anybody coming here for the first time want to know what this is, I'll give you a quick visual of that, and it's this section here. Awesome video I found here, animation. That's the piston. Here's your hydraulic line coming in. This holds it, seals the hydraulic line to this casting. This would, I guess, would be a bleeder valve down here if you could translate that to a corresponding. Here's your brake pad on the other side, and caliper. So there is where he's showing the corrosion is right about here, or I'll just call it corrosion. Let's bounce over. And let's go back to his comments.
This caliper piston junk. And I can clean this up as best I can, but when you run into this is what really causes the problem, because there's a really tight interference fit between the seal that's in here and this piston. And if
that's the back of the piston. Now, if there's no, remember the brake caliper, if you look at your master cylinder, if you look into your master cylinder and you have no fluid dropping, well, this could be stuck. You're still not losing fluid, incidentally.
If it gets all rusted and pitted like this, the seal will catch on this. It will damage the seal over time, and away you go. We will do our best to clean up what we have, because remember, this is more temporary than anything.
And he's from Ohio. I don't know the economy up there, but he often does things like that. He'll put that back together. Whereas, where we're from down here, Philadelphia area, you get sued for something like this. You'd have to tell the person all types of things why you would reinstall that. They basically have to, sign a piece of paper saying that, hey, this thing is totally, it's a danger at this point, because it can break the seal, which if it breaks the seal, you now will lose that pressure in that system. And that system is minimally composes of 2 brakes, not just 1. So let's go here. On these type of cars. So you could have an individual type of check valve on it, but they don't have check valves on these.
Here inside the caliper itself, there are really only 2 parts to this. The first is the dust seal, which honestly, for me, has given me the most trouble in the past. I probably should go get it.
So that dust seal you see him pulling out would translate to this seal right here, this rubber gasket here. And we'll use his terms and slide it over.
A screwdriver or something to pull that out. Oh, there we go.
Again, this guy's got 1 million plus subscribers.
All right, so we've been able to peel that.
And a lot of people didn't know. They're saying, thanks, I didn't know it worked that way, etc. It does not work this way, is how he's going to describe it. It does not. And this is not the problem with this cylinder, with this piston, or this caliper system.
This is the dust boot. Sometimes these will rip. And as I said, this is just a dust boot. This is just there to keep out the contaminants and everything else. Is all this is for. All right, next we need to remove this.
This is very important. This part here is where he's going to get it wrong, but just take a look at it. It's a seal. That's all it is.
Square cut seal. And this is really what makes the caliper work.
Not what makes it's part of what makes it work. So with that seal being loose, you will get you will get loose. If it's not a tight fit, a seal, then you could get fluid coming around there, and your hydraulic, you'll see it translate that. You'll see it in your master cylinder, and you'd have a leak. But let's go on. Pausing. Back here is where the fluid builds up. I'm not saying that's the real fluid. Maybe it is, but maybe took it out there. That might be the real hydraulic fluid in the back of this piston. Okay. So the back of that piston would look like this right here. Hydraulic fluid back here. Moving over. Let's go back to what his statement. This is where he's going to get it wrong.
It sits in a groove in there, but this is it. This is the heart and soul of the caliper. And the reason this works,
that's his opinion.
So this helps seal the caliper piston.
Doesn't help seal it. It seals the caliper piston. Doesn't help. That's what it does. Okay, so let's go on.
But it also works as the return spring for this.
Now, this is the crackpot stuff. And I'm sorry about calling him crackpot, but he's 1.2 million subscribers. He's a mechanic. He doesn't have an excuse to say this is a return spring.
And soul of the caliper. And the reason this works, so this helps seal the caliper piston, but it also works as the return spring for this. The reason why it was hanging up and the reason why the caliper was stuck on is because this seal was not working as a return spring. So when you apply the brakes, fluid pressure comes to the back of this piston, and as it does, it rolls this seal over. So the seal is pushed out like this, but as soon as you release pressure, that square cut seal helps pull it back into place. It's just a very minute amount, but it's enough during the course of the movement of the caliper to cause the caliper to work.
Okay, right there. That's enough. That's just lunacy. All right, a couple of people stated, "Oh, I didn't know that's how it works. Thanks a lot. Doing it for years. Explains a lot, etc." It's wrong. Not even a percentage correct. It's a seal. It locks in there. And so that's where my trigger is with that. Now, Chris, I'm not done with this. Chris Fix also is one that has millions of subscribers that puts out bullshit data. Now, I did a video on him on this channel also. And let's see, open link, a new tab. So I get people.
Hey guys, Chris Fix here. Today we're working.
I've been blocking comments, 4.5 million, because the comments are wrong, and a lot of them have been attacking me personally for attacking Chris Fix. Oh well, tough shit. And so I don't put them out there because that doesn't serve any purpose. Besides, YouTube would like they even accept negative comments as positive comments for a channel. You ever wonder why people leave those negative comments up? Because it brings traffic to their channel based on YouTube's algorithms. They don't care if you're calling a person a name. That's why those people leave it on there. I do care because I want the message to be what it is. I don't need your traffic. I don't want the money that's related to that traffic, because people might believe some of the negative traffic. It's because one negative thing has more weight than 10 positive things because it gives you doubt. I don't want people to have doubt on what I'm saying, so I delete their comments before I see them first, and then I delete them. 16 hours ago, this guy writes this, or this person writes this, Danielle Majera. It says, okay, this is about my video here. Let me just click on it. I did approve their comment because of this video before I loaded it, so I didn't quite read it. Here's my video.
For educational purposes.
And I said for educational purposes only because it's what it's for. I get 9,285 things. I had Chris fix terrible brake advice fail. How to fix uneven brake wear is what he stated. So this person wrote 17 hours ago. Okay, at 7:20 when you were talking about how they would never warn. You are correct. That's it. But they have a but part. But I think he might have accidentally thrown away the pads while not thinking about it. So he grabbed those just to make the video seem smooth. So this person can't accept that the guy gave wrong data. They clearly see it's wrong data, but they can't accept it. They can't live with it. That they're the infallible Chris fix, if you will. This is what we have in our brain. We can't accept that like me, I make mistakes, but I offer you guys to help me to find my mistakes. Sometimes these videos are live. I quote myself one day saying something like 10 times 10 by 10 was 20. I made a joke of it in my comments. I said, you know, obviously 10 by 10 is not 20. So I let it ride. I don't need some, you know, please correct me if you see I'm doing anything wrong. You know, this stuff happens when you're doing live videos. This person cannot accept that the person that they're worshiping, if you will, this Danielle, can't accept it. The data is clear, right? So they make up an excuse for them. There is no excuse for what he did. He stated that his whole video, his premise was on piston, the uneven brake wear was from brake pistons, brake pins. Let's see, is it brake pins? I got to remember what the hell it was. It was right, 100%. The brake pins, the slide pins. Where the hell are you? All right, let's move on from there. I'm going to just show you real quickly.
And educational purposes, showing that
You're hearing it.
just because you see it on YouTube, just because you see it there, doesn't mean they know what they're doing. And don't follow their advice. You've really got to know what you're doing. For you guys think you're going to work on a brake or something like that, specifically, these are brakes. This guy calls himself Chris Fix. He's kind of fun to watch just to, you know, you just watch people because, you know, you're kind of fun to watch. But in this case, this guy's so far off the mark and so full of it. These
guide pins, right? Guide pins is what he's going to refer to as the issue with these brakes. That's what it was. Guide pins.
Let's move forward again. Sorry about that. I'm trying to hurry.
Now, and that's good.
That's what he's saying is wrong with this brake system here in this car. Let's take a look at the brakes real quickly. I'm backing up in my own video here. This is the wear of the brakes. As you can see on the one side, this is totally uneven. The one side is totally shot. On this side, you do have some meat, as we call it, right? You've got some brake wear, but you got a significant amount of meat. On this side, it's really running down. Now let's fast forward in my own video of his video, and you know the people down in the comments I'm working on, and let's jump forward to his opposite end of his own video. Now he states here that this is the other side of the brake system, the right side, and here we go.
So let's back it up.
He says guide pins are okay on this one.
Let's see if I can get it to back up. Right there. You saw it. Right there. 634, 635. Nowhere.
He says even wear. Those are brand new. These are unworn. I mean, not brand new. They're not brand new out of the box. These were sitting on that car apparently, or a car. That car, he says it came off of. Did a video on it. You guys go to the video if you want. He's claiming that these came off of this car here, which I accept. If that's so, you have no piston action going on that side. And if you remember in the beginning of the video, I showed you that when you apply force, and I'm going to show you more of that. When you apply, let's stop there and go to that video. This is part of my education for you. So let's go to a beautiful video someone has here, an animation. And let's see if it's going to be to the far. Oh, okay. Back to this one. So a beautiful animation. That's one. And number two animation to help us will be this one, to help us describe it for you. Now I have to narrate, otherwise it's no longer educational purposes, and it's copyright protected. Under educational purposes, I can share this video not all of it, parts of it, and describing it. So here we go. So this is their animation, beautifully so. Here's your master cylinder animation, okay? So you have your two wells. Your two wells are separate because brake systems are divided into two sides for safety reasons, not a single well. So typically it would be the two front, two rears, or across from each other. So if one was to fail back here, let's say that caliper fails and fluid just starts flowing out through that seal. As you apply the brakes, that fluid would come out here and you would no longer have hydraulic force. You would crash, or you couldn't come to a stop. Ultimately, if you didn't hit anything, you'd drift to a stop, right? So they make two wells, and you would feel the brake not grabbing. You would know something's going on, and hopefully you get to a mechanic, a real mechanic. They put them opposite each other so you don't have, if you had them both on the one side, if we had the front well only, if this was failing, in theory, if this one side was failing only and you went to use the brakes, this could pull you to one side and cause an issue of pulling you into something. So they'd like to make it opposite. Some manufacturers like making them on the same side. High tech wise, you'd have a check valve on each one of these, which would be weird because then the pressure would then translate to just the three remaining. So I'm not going to go down that path with you. Now going back to the cylinder, the brake master cylinder. Let's see if we can go to this animation.
Since there are two brake circuits, such a
I'm going to wait for them to put a slot inside here to talk before I start talking.
master cylinder is called tandem brake master cylinder. The ports of the master cylinder.
So I need them to show the holes. Let's go to the top. So even this could be clogged up from your fluids, which would give you a restriction. Air pockets, things like that. If it's clogged up, you would have a bleeding brake issue in theory. Let's go. One's going to be pushing fluids in. One's going to be a check valve in theory. Let's go.
To the brakes are located on
Compensating port, breather port, allowing the pressure to come back.
the side of the cylinder.
This is where that other guy, whatever his name is, Eric, the car guy, says that it's a spring return on the rubber. It is not designed to flip around and act as a spring in any manner. In any manner. That would be friction. That would actually restrict this movement. All right, this is what I was waiting for. Notice that, see this hole here? This is where the fluids would flow into this compartment. This compartment, if you will, is from this gasket to this gasket here, what you see in black. I'm calling it a gasket. You can call it a seal. Over here would be a port leading to your brake lines, two brakes, let's call it. Same thing here would be a port. This is a cutaway. So another port leading to two brake lines also. Here's your port here from this cylinder. They're separate. They do not share together. This distance matters also on its compression. How much fluid is compressing compared to almost this compartment also compared to this one, how much it's compressing. You can see this design allows for something in there, some further stroke. And that's what it's would be called, stroke. All right, so let's go there.
As soon as the driver depresses the brake pedal.
So right now we have no brake pressure on the, we have brake. Let me see if you guys are there. Nobody's, no comments, good. All right, so I don't have to respond. So right now we have no brake pressure on, I should say no brake pressure, no applied brake pressure. That's running your calipers. I'm trying to get back to the video, believe it or not. All right, so right now you should have a release, no brake contact with your calipers. If you do,
Pedal. The push rod pushes.
if you do, you don't have a proper return. You need to figure out what's going on there. You need to clear your lines out, etc. What is happening is you've created somehow a check valve, if you will, with pressure staying on the other side. Now that can be because of that. As it released, it can be getting stuck up on the back side of this. That rust could be holding it, somehow being contact. This could be cocked in one direction. This wall, cylinder wall, can cock also, get stuck in the wall. It could be debris back there, getting stuck between those two walls, this piston and that wall. And you say, well, how does that happen? Well, this is debris, if you will. And how would that happen in theory? So I have to give you a theory. Is this product back here, over all the years, the rust breaks free. This is hydraulic force. They're very great. As you apply the force behind that in that caliper, behind that piston, this rust can start working its way on the side there, and that creates a friction contact point to allow it not to retract. It can cock one. With that said, it can get on one side, in fact, and when you apply the pressure, it keeps releasing back, but not fully, and you're getting your contact, and you're heating brakes, and you're dragging brakes. So this is where you need to address cleaning this up. If you can, you possibly have to replace this thing if you can see it's not playing ball. Is it the contributing factor? You can see you're going to have some thousandths of an inch around this wall, and that's what I'm saying, that this debris can get behind there and start pinning you, start screwing your day up. Now there is the flow here. Let's look at this, and this animation is beautiful. Is a beautiful animation. Let's look at the beginning of this. So on one side of this is your piston. As this force is applied from the hydraulic force, it pushes this back in this wall, pushing this piston out. This allows that guide pin that Chris Fix was alluding to was the issue. Can guide pins be the issue? They'd have to wear unevenly. What would make them wear unevenly? You know, what would do that? This piston's coming out, hitting theirs evenly. The pins are of equal length. It would be pretty tough for me to give you that one. I'd have to say this piston would have to hit this unequally as it applied the pressure. You could have your rotor also being uneven and warped. You slammed on brakes, your rotors are warped. It could also create a wobbling effect. There's quite a few things, but if it's uneven as that, you need to address why it's uneven. It's going to be back here in this system here, why it's uneven. Hell, I can even give you an example why it'd be on that side. It could be the brake caliper has these little standoff braces. The squeaky let you know your brakes are running low. It could be all that stuff. Okay, so watch how when this slow animation, the backside. In theory, when this applies the force here, they both will contact at the same time, both sides of the caliper, applying equal forces, one by the other. The clamping action, if you will, of this, it's like a pair of pliers. So this will act like a pair of pliers. If you put your finger in a pair of pliers and you squeeze down on the handle, is it equal on both sides of the pliers? You know, that is. It's really not. If you have more force on one side of pliers than the other, then you're probably pushing against the other one than the other one. So it's like that. Now this will be like a clamp. How about that? If you're applying clamp force, like a screw clamp, is it equal? One can resist more. Think of it like that. And you want this thing to be equal on both sides, ideally, so the pressure is equal. Here we go. So this is it's showing you the action without the
guide
caliper.
pins on the caliper serve this purpose.
To slide. So if you could get one of these guide pins inside here also to get debris in it and start freezing up and locking up, then I could show you where that would allow this to cock and hit one side, which could explain this. It could. I mean, if I'm trying, I like to play devil's advocate. I don't just like to beat somebody up. I like to say, well, let me see if I can see your side. This makes me neutral, I think. I recognize my bias, and then I try to address it. So if I could force myself to, if I could come to this conclusion that guide pins created this, I would need to see a failed guide pin, one that's scratching and really holding it up. And as you're taking it apart, you would be able to determine that, saying, here it is stuck. But I don't see that in this one. His guide pins he does reveal, and they do need to be replaced. You know, just trash them. They've got this significant amount of wear on them, rust on them. But I would have to see it. I can't trust the data here. He was in for a penny, in for a pound. Once he started saying guide pins, he stuck to it. He did not move away from it. And I don't see the guide pins when he played in this video as being an issue, especially based on his last, the new brake system that they put in there. You'd have to watch my video on that and explains it to you. Back to this now. So we go back. So I try to, you know, I can't see it. I can't see it. Those things would, you know, the force that these apply, I can't see that guide pin holding it, especially since he recycled the same guide pins and also the track. He didn't clean the track out as far as I recall. Here we go. Guide pins are pretty smooth acting.
When pressure is applied to the caliper piston, the caliper piston is axially displaced.
Displaced.
When the pressure decreases, the caliper piston returns to its initial position.
Because it was under pressure. To get to there, it was under pressure. Maintain pressure by your brake pedal through the master cylinder. Once you release that pressure, it has nothing to hold it there anymore. It releases. It releases.
First,
You're seeing it, it's acting individually. The guide pins play no part in this until you secure it to this side with the other caliper. Watch.
the caliper piston presses the brake pad against the brake disc.
Upon pushing against that one, the other one, it will push. It's not pushing the caliper out of the way. It's not pushing it all. It's applying pressure at this point. Once it does that, this, since it's applying pressure, will act like a clamp. This will now act as a sliding clamp. This side will slide over to meet contact with this other side of this rotor. At that point, this pressure increases. This increases the clamping action on this caliper, an equal clamping action. The first contact is always this side, though. Always this side. So this is why you're going to get more wear on this side than that side. It first comes in contact, the slide happens, this clamping slide, if you will, happens. Then it comes in contact with this one secondarily. As you can imagine, if you can get this thing to touch first on one side, see, that's the thickness of the pad, on that side first, the clamping action is still going to take place. It's still going to do that as it rocks into place. And if you can imagine, it can get out of alignment that way. If you can imagine that, saying it's the pins first. It's not that much play in the pins. It's going to line back up again and come into place. You just can't get it that way. But you do have, in this case, his pad setup is the back end coming in contact first and not the front. And incidentally, I think he said in his video that he had them backwards, or I said he had them backwards in his statement, that the leading edge was there. It doesn't matter. So many ways I just showed that he was just pulling, just slapping together a video with the wrong knowledge. So now you can see the forces, the hydraulic forces, this is your brake pedal apply. Clamping action's there. You release it, this release, and it's not much. It's not this huge amount that's going to pull away. It's a little bit, it breaks contact. That's it. Now, if you've got a stuck caliper, it will take longer and you hear some squeaking and all that. It will plane off. This will spin and it will plane off that caliper until it no longer sticks. Repeatedly, over and over and over again, planing it off each time. And I say planing it off, the friction will be created and they will swap materials. Now let's go further in this diagram.
Since the brake disc is fixed, the brake pad and caliper piston cannot be moved any further. If pressure continues to be applied to the caliper piston, the entire caliper must slide backwards.
This right here, slide.
Without pressure, the caliper and caliper piston return to their initial position.
And that's the size of that. It's going to break a little bit, not so much. So here's a side view with probably more of an exaggerated gap. But again, here's your forces, and let's go for it. Let's get rid of his narration because I'm narrating. So again, this is the slide action is going to take place within those pins. You see the initial contact, and I didn't watch this video actually. This now it's rubbing, right? It's not doing anything as far as slowing the car down at this point. It's made contact, not until this one takes place. It's just got some friction. You keep it touching like that for just so you ride your brakes. However, in this discussion, you ride your brakes, you're going to heat your brakes up, and one side of them for sure. And this is why you shouldn't do it. Now this will be less effective. If you're riding your brakes. And when this one comes in contact, this will now participate. And now it's participating. The clamping force action is happening, and now you saw it in reverse action. Let's see if they have one with the slide in it. I think they do. Let's see if we can jump forward on that. Okay. So this is the top view. Give me like I think like 3 minutes. I think I should be about done. Okay. I don't need that detail. Scrubbing. I'm looking at a scrub. I wanted to show the slide action. Let's go back to it. Okay, let's go to this one. Here's your slide view. Let's see if they can show the slide. And all it is a slide. and it's a clamp. It's all this thing is doing. It's a slide. Now, it's very difficult to get this to stick. I can't come up with it. I've never had one, in my vehicles ever stick. I've had these things go south on me. All the other issues go south. And we're done with that. So that explains, let me get rid of that video. So that explains that one. Waiting for the video to close down. And let's go back to this one now. Let's see what he... So this is where
it sits in a groove in there, but this is it. This is the heart and soul of the caliper. And the reason this works, so this helps seal the caliper piston, but it also works as the return spring for this. The reason...
See, return spring. So just because he's got 1.2 million subscribers and he's Eric the Car Guy, does not mean he knows what he's talking about. The guy, again, this guy has some great resources. I'm watching his videos with him taking down a car with using a machine shop, and you can hear him. But now that I understand, not just because of this video, it's another couple of videos where I knew, wow, this guy's, YouTube, it's amazing, that some people don't know what they're talking about, and yet they're very successful when they get, tons of people responding and things like that. Return spring, this is not, and I guess that's my point. Don't get too crazy over everything. Do some more research. Oh, I don't know when you would think you were done at this point, right? If you were here. So I don't know how you can make the next step if you think that, like Eric does, that he thinks this is a return spring. 1.2 million subscribers. Priceless. This data is priceless.
Why it was hanging up and the reason why the caliper was stuck on is because this seal was not working as a return spring. So when you apply the brakes, fluid pressure comes to the back of this piston, and as it does, it rolls the seal open.
Wow. And I mean, you got to realize it, guys. This guy's got 1.2 million subscribers based on mechanical channel, mechanics of vehicles. He's working on vehicles right now, someone's car. This is the amazing part about it. Someone's hired him, or is this his own shop? I have not gone into that detail. And so, I don't know what the laws in Ohio are about mechanics, but this is the knowledge that's being shared forward 606,324 times. Maybe I counted as 4 or 5 times. But wow, I find this is the part I find amazing. And how far will this go forward into generations? Believe it or not, I share it to you. I share it to my son. Things like that. If I had, things like that, and things like this. This guy, Brake Channel, he's got 4 million subscribers and played hundreds of thousands of times. I think 644,000 times. This stuff is deadly. This is deadly information getting out there about brakes. And I wish there was a way that, that this could be altered, but I can't change anything besides make my video, and hopefully you guys will understand it. Let's complete this with this.
Is the first rubber piston cup over the compensating port.
So at this point, you've got your dual cylinders, your master cylinders above us. And I'm going to end the video after I explain this. So right now, the port is still open. No force is being applied on your brake pistons at this point. This is your brake pedal action going on. Not until you close this port will brake forces apply to this port. This one is still trailing. So front brake pressure sometimes gets it more than the rears in vehicles. So, maybe this is designed to apply brakes to the front, and these are designed to the rears. Because I'm going to show you, we'll look at this video and we'll see that this port will be fully closed. This one will be partially open. So let's assume that that is the front brakes, because nobody applies brakes to the rear as far as I know first. All right, here we go.
Consequently, pressure builds up in the first brake circuit. As a result, the second rubber piston...
Not until now. So it just crossed. At this point, pressure is being applied in the first brake circuit, let's call it, from the hydraulic lines. The rear brakes have not experienced any force yet. Now, in this, if I'm considering this the rear, not until this gets sealed. And then it will start experiencing a force, because as long as this is open, the forces are equal everywhere. And it basically is just back pressure, and back pressure is not really legit. It's pressure. But I still resort to back pressure in my terms.
Cup is moved over the second compensating port, and pressure builds up in the second brake circuit.
Not until now does pressure build up. So now pressure is building up. So pressure is already applied here. The brakes are experiencing force, closing of the calipers. This one, they're just about approaching, if you will, the caliper closing. And we're now going to apply pressure uniformly from a relationship to their own ports. This has a port here, and this one has a port. So two calipers, let's call it, and two calipers. This is called stroke. So you can imagine a little bit of brake pressure is being applied here. This one is experiencing, well. I don't see this shrinking in here. Ideally, in this diagram, the spring would be closing, I would think, and more pressure will be being applied here. And in this diagram, this spring should be closing and more pressure being applied. Oh, there's a spring. There's a spring coming and closed. All right, so here this would be, I guess, a bushing keeping these two separate from each other. So now more pressure is being applied there. Now they're doing a reversal, letting off the brake. So brake pressure is still constant. A little bit of, I'm sorry, there's some expansion inside there. So some hydraulic forces have been reversed. And not until you get here where they really start releasing. And then that would be the rears, I'm going to say, and that's going to be a front brake's going to release last. Right about now, they're releasing on the rears, and so that's released. And then here on the front, the way I described it. Here's your hydraulic lines, and let's go ahead and kill that music they have there. And let's fast forward this a little bit. Oh, good rendering. I forgot this was present. Let's go ahead and hit this. Okay, I'll screw that up. Let's go here. All right, so back to play. And it's showing the forces coming down the hose line. And there's your contact, your hydraulics. Now, they're going to do reversal too soon when they do it. You see the line coming this way. They're not doing a reversal. There is no, well, there's a slight reversal, but not flow like that and not flow like that. This is experience showing flow. It's just a release of pressure. Flow is not going to change until you clear these ports. Continue a release. That one's released, as you can see there, and now this one is released. They're still showing it going backwards. It's a significant pressure drop. And you come to zero. That's the size of that. So I hope this was helpful for anybody who's trying to understand what's going on with the brake. Now this is Pascal's law. Pascal. Let's see if I got Pascal here for you real quick. And let's see, I'll jump back out of that one. I did not watch this one. I think I watched a section of it. And I only said I'm just going to grab it because I can scrub this stuff pretty fast.
Exerts a force on the brake pedal.
All right. So
it sets the brake fluid within the brake master cylinder in motion.
Let's do this. Just come here. So there's brake fluid. There's my little, I don't want that. There's nothing to show here. That was nothing. This one really, I guess I didn't really need to show. P is force. And Pascal, where are you, Pascal? Oops, I didn't put a Pascal video up. Hopefully they'll know I meant the apostrophe. Here's your Pascal's law. It's very simple. Let's see if I can fast forward it. This is all we're talking about. This is it. A change in pressure at any point and an enclosed fluid at rest is transmitted undiminished to all points in the fluid. So undiminished, it's going on all sections of it, unless it's blocked. In which case it's going on to the block section, the chip, the crimped section, etc. The blockage. So there's some awesome formulas on this, size of this compared to the size of this. This really matters. Area equals force. This is some really cool stuff. Relationship to brake. Why a little bit of that, little bit of cylinder pressure, little bit of pressure on one side can equal so much on the other side, vice versa. It's some amazing, amazing forces. This is all we're talking about. This is it. There's nothing magical about brakes. They're beautiful, but magical about hydraulics. They're just so beautiful. You see 100 newtons, I believe you're saying. You can look what you're getting over here. It's just beautiful, absolutely beautiful. This is your human blood pressure in your heart also. You pause this. This is your heart, why your heart can do so much. That one little pump. It doesn't matter if this is Pascal's law, basically. That it doesn't matter if you've got all those arteries and all. One little touch of over here in your little heart translate the pressure movement everywhere else. That's why you can take the pulse at, you know, different parts of your body. It's same everywhere. Same everywhere. It's beautiful. Then it's a rest, then it's a pulse. It's a frequency, right? Up and down. Hydraulics are really very simple. They're very simple. They're not as complicated as all this reversal and craziness that's going on here. And I don't mean him to be crazy. I'm not saying that at all. I did post a video on my channel mentioning his name and all that. Hopefully he'll come to my channel and say I'm a correct it and everything else. And if he does, I'm a good guy. I will take down, I will amend my statement. I'll allow him to comment on my channel, things like that, to correct, to say, oh, I got this wrong. But you guys know I talked about the amygdala and all. There's more. It's probably impossible for him to change his mind, his position on this. Just like my video got over to Chris Fix and all that. It's impossible for him to comment that he deceived people with his video. My theory says that even though Eric does hire professionals to help him out, I've watched him with those professionals. When they show him something else, he goes, oh, and almost as though whatever. And he said, oh, I do it a different way. And it's amazing because a lot of times Eric's ways, well, let me put it this way. He hires a professional on this, they'll tell him he's doing it wrong. And my guess is Eric would say, oh, I would have done it a different way. Or my theory would say that Eric would say, well, it does flip over a little bit. That's what my theory would say, that's it. I don't think he's able to reverse his decision on that. That's interesting. I'll delete the back end of this video. Or you know what? That's the part Eric can comment on because I love the amygdala. We can change our position if we open up our files to source data. That means that so Eric has a conclusive file. I'm going to end this video with this because I have to talk about my amygdala. Eric has a conclusive file, meaning he swears that this flips around and acts as a spring. That's the conclusive file. The source data of that Eric's file is, I don't know, that Eric has determined through whatever his experiments or learning, whatever they are his source data to him to make this decision. Maybe it's his own brain that he looked at all this and said, oh, this must flip around. So that's the source data. And the conclusive file he made was that this is a return spring. Maybe why did he determine that? Because he had in his mind that something must have to make this return. And Eric does not understand hydraulic forces, the master cylinder, how it works, and Pascal's law. This is the limit to Eric's ability. 100%, I can make that conclusive file because we're talking about Pascal's law in this whole system. He mentioned piston. He doesn't understand it. So he only has limited source data, and this is what he determined was what's going on here. With that said, if Eric listens to my part of the video, in theory, he should be able to say, oh, you know what? I'll take on new source data. Now I understand Pascal's law. This is a conflict of my spring data, that this is a spring now, and both of them can't live together in my mind. So in other words, guys, 2 + 2 = 4, and 2 + 2 = 5. Those two files, those two conclusive files cannot live in your mind together because most of us know that 2 + 2 is 4. There is no example where you can make it equal 5, right? You'd have to play with your mind to make it equal 5. This cannot equal 5 also. It cannot equal a spring. But Eric's made it 2 + 2 = 5, if you will. Eric's made this equal something it's not. With that said, our mind, our amygdala in our mind says he cannot change his mind, that he cannot change it. He has to dig in on this and say how somehow it's experiencing this twisting action, that somehow it's a spring now. He can't change his mind on it. It's not possible. Just like Eric guy, the other guy couldn't. The other guy couldn't change his mind on it. That's the way it is. So this is my whole thing about the human mind part, is that where I can change my mind because I open up to everyone. If you can show me this is a spring, and call it a spring. Now, with that said, would my amygdala allow me to keep my video up? Hell no. I have to tell you guys, honestly, since I was wrong, I couldn't leave it up. It would be an attack on me because that would be like me saying 2 + 2 is 5 to everybody. Once I found out it was 4, I wouldn't leave up a video that says that it was 5. You're like, you dummy, remember when you used to think it was 5? No, I had to protect myself. And that's what, not my character or anything else, your mind. And that's why we can't change our mind a lot of times, because we can't take on new source data. I'm willing to take on new source data. If somebody shows me this is a spring, well, I'll just call you an idiot. But here we go.
It sits in a groove in there, but this is it. This is the heart and soul of the caliper. And the reason this works, so this helps seal the caliper piston, but it also works as the return spring for this. The reason why it was hanging up and the reason why the caliper was stuck on is because this seal was not working as a return spring.
That's it. That's his conclusive file, a return spring. So unless I can get, so one more thing before we go. So there's no way, so I'm attacking Eric in his mind, whether he likes it or not. I understand that. I understand that. So there is no way that I can attack Eric down in his comments by saying, hey, Eric, can I open your mind up? There's no way I can say, Eric, please look at my video on this, that this is not a return spring. That's an attack on Eric. There's no way he believes it's 5. That's it. There is no reversal of that. Sorry, guys, that's the way it is. I definitely would welcome conversation on this. I love the amygdala. It's what's holding us back with growth, with everything we do. I'm terminating this video, and I don't know how long it is, but I'm sure it's damn well long enough.
Just comments.
And wish you guys success.